Today we're going to be introducing our fourth and final transformation, which is called dilations. So if you remember back to our previous three transformations, we did reflection, rotation, and translation. Those all kept our figure congruent. Congruent means that it's the same. So we're just moving that figure across the coordinate plane. It stays the same shape and it stays the same size. With a dilation, it produces a similar figure, which means that we're going to have something that is the same shape. So we're going to say it's the same shape, but it's different sizes. So different sizes. And that's going to be the difference. That's why we're doing dilations a little bit later. So we'll talk about dilations more so on our next notes day. Today we're talking specifically about similar figures and our scale factors, which all lead into our dilation. So today we're going to be looking at two different figures. We're going to be finding the scale factor and doing our proportional relationship check. When we do a dilation, I'll give you the original figure and I'll give you the scale factor, and you have to produce the similar figure on the coordinate plane. So we're building up to that. So let's start off figuring out what a scale factor is, because I've said that a couple of times. We know what similar figures are. Similar figures are same shape but different sizes. A scale factor is a multiplier used to either enlarge or stretch out, or to reduce, which means shrink, the size of a figure. The two figures are similar if the corresponding angles, I cannot write with this thing, angles are congruent, so that means that they're the same. So if the angles match up, it's good. And the ratio between the corresponding measurements are equal, meaning the corresponding measurements are proportional, which is why we have our proportional check over here. To enlarge a figure by a scale factor, so remember, enlarge means make bigger, the scale factor must be greater than 1. And so we'll have a number like 2 or 3 or 10 or 100. If we wanted to reduce the figure, so make it smaller, the scale factor must be less than 1. And so that means that it's going to end up being a decimal or a fraction. So if we multiply a number by 1/2 or 0.5, it's going to reduce the figure by half the size. So let's go ahead and look at these examples below. So our first example here, we've got our original figure and we have our similar figure. We're going to have to figure out the scale factor for this. In order to do that, I have to start by matching up the corresponding sides. So I can see that it was rotated a little bit, but if I'm looking at my right angle and I'm looking at what my hypotenuse is, I have my right angle here, and then directly across is my hypotenuse. So underneath is going to be that 2, underneath is going to be that 4. So the 2 and the 4 go together. So let's look at the other side. That 2.5 and that 5 go together. And so what we're going to do is we are going to say that we are multiplying, because that's what a scale factor is. It's a multiplier. And so it doesn't matter which corresponding side you pick, just pick one of these pairs. Let's go ahead and pick the red pair. So what I'm going to do is I'm going to take my original side, and I know I'm multiplying it by a number. I just don't know what that number is yet. Whenever we don't know what that number is, we always use a variable. So you could use S for scale factor. I'm just going to use X because I'm basic. And then we're going to set that equal to our similar figure. So we know when we take 5 times our scale factor, we're going to end up with this 2.5. Because that's what it's telling us in our example here. And now we just have a one-step equation. So we know with a one-step equation, we're going to draw our line, we're going to be solving for our x variable. To get our x variable by itself, which is our goal, we have to get rid of this 5. I don't see any sign between our 5 and our x, so that means that we have multiplication. Opposite of multiplication, division. And we want to get rid of that 5, so that's what we're going to divide by. 5 divided by 5 gives me a 1. 1 times x is just x. And so we have x isolated, it's by itself, so that's good. Now we have to do 2.5 divided by 5, and I can use a calculator or I can use my brain, and I know that that's going to be 1/2, or if you used a calculator, it's probably going to tell you 0.5. And remember, those mean the same exact thing. And so we know what our scale factor is. It's 1/2 or 0.5 for these, this example here. Let's double check. So what we're going to do is we're going to be setting up a proportion. So remember, a proportion is 2 ratios or 2 fractions that are going to be set equal to each other. So I'm going to start off drawing the 2 fraction bar lines with an equal sign in the middle for a proportional relationship. I'm going to be looking at my original figure, and my side lengths are 5 and 4. So we'll go ahead and put 5 up top and 4 up top. And so we've got our top being our original figure. The denominator, or the bottom, is going to be our similar figure. We have to make sure that we play our matching game. What number matches up with our 5? That's going to be 2.5. So 2.5 is going to go on the bottom here. And then what number matches up with 4? 4 and 2 to go together. Then you're going to be checking for equal cross products. So that means we're going to be doing our cross multiplication. So let me change up my color here. We're going to be taking 2.5 times 4 and 5 times 2. When I multiply 5 times 2, I'm going to end up with 10. If I multiply 2.5 times 4, I also end up with 10. And so since these two sides are equal, I know that this is a proportional relationship, which means these are similar figures. So while it seems a little bit silly now because I'm telling you that these are similar figures, it's going to be really beneficial in the future just to make sure that you get the right side lengths. And we're going to have some homework problems that are asking you to check to see if these are similar figures, and you should use the proportional relationship check to figure that out. So I'm going to go ahead and clear my drawings. So if you still need them, pause the screen. All right. So I was kind of talking about this, but you know that 2 figures are similar. You spelled that right? Similar. Yeah. So you know 2 figures are similar. If you know 2 figures are similar, you can use the corresponding measurements to set up a proportion, which is what we did. This proportion can be used to calculate the missing side length And so what this is saying is another way to use that proportional check is to find the missing side length, which is what we're actually going to be doing down here. We're going to be finding our scale factor to figure out how much we're changing from our original figure to our similar figure. And then we're going to use that information and we're going to set up our proportional relationship to be able to solve for our x to find this side length down here. So let's go ahead and solve this problem together. So what we're going to do first is figure out our scale factor. But before we can get going with that, we have to play our matching game. So we're going to match up our sides. So this 1 centimeter goes with this 2.5 centimeters because it's both on that left side there. If you notice, the shape did not change at all. We did not rotate it. We did not reflect it or anything special like that. It's the same exact position. So I can just match up those 2 side lengths. That 2 centimeters matches up with our x centimeters. And remember that x is unknown. So we're going to figure it out later. Now we're going to go ahead and do our scale factor. To figure out the scale factor, we're going to use the two numbers that we actually have. So I'm not going to use the green, I'm going to use the red numbers. And so we're looking at our original figure, that's a 1. We have to multiply that by some number, which is our scale factor, and that's going to give us this 2.5 for our similar figure. We just have to figure out what number we're multiplying it by. So it's a one-step equation. I'm going to draw my line. We're solving for our x variable because that's our unknown. We want to get rid of this 1. So I see multiplication. That means we're going to do division. And we want to get rid of the 1. So we're going to divide by 1. That goes away and we're left with our x. 2.5 divided by 1 is just going to be 2.5. And so that's what our scale factor is. We're multiplying these numbers by 2.5 to get to the other number over here to produce our similar figure. And so that's going to be our answer for this one. Now we're going to have to solve for x. So there's a couple different ways you can do this. So if you find a way that works better for you, go ahead and do it. Just check your answer with mine to see if you are correct and if your way works. So we're going to be setting up our proportional relationship. So that means that we have to have two ratios that are set equal to each other to make our proportion. I'm going to take my two red numbers and I'm going to put them like this. And I'm going to take my two green numbers and I'm going to put them like that. And now I've got my proportion. I can do my cross multiplication. So let's see, we're going to grab these colors. To do our cross multiplication, we're looking at our diagonals and we're just going to go ahead and multiply them. So 1 times x is going to be on one side and 2.5 times 2 is going to be on the other side. To be able to solve for x, I have to go ahead and simplify, and then it's just going to be a one step. So I've got to simplify this right side, 2.5 times 2. That's going to go ahead and give me, let's see, 5. And that's equal to 1x still because I didn't do anything to the left side. I just simplified that multiplication there. Now I have to divide by 1 to get rid of that multiply by 1 that I see there. So divide by 1, and I'm going to be left with x equals 5. And that's going to be my final answer. So to determine if two figures are similar, you first look at the shapes. Remember, similar figures have to have the same shape. Let's get this out, same shape and different size. Next, you're going to check whether or not the ratio, and so those are our fractions, or that comparison of those two numbers. So we're going to check whether or not the ratio of corresponding sides. So corresponding sides means that we're matching up those sides. So corresponding sides form a proportion, which is what we did over here. Remember, a proportion is formed by two equal ratios, which is what a proportion is because we've got two ratios over here or two fractions and we're setting them equal to each other. So that proportion is correct because it's formed by two ratios or two fractions that are equal to each other. So I'm going to go ahead and erase my screen. If you still need it, pause the screen. Okay. And now we have our last example. So we've got our original figure and our similar figure. We've got all the numbers that we need. We're going to do a proportional relationship check just like how we did over here, which is where we're setting up our proportion and we're going to be solving to see if it's an actual similar figure or not. So I'm going to get you started on this and I'm going to ask you to finish it. So remember, a proportion is two fractions that are set equal to each other or two ratios. and we're going to be matching up these numbers. So I can see that this is a rectangle. So the smaller side is 3 for our original figure, and the smaller side is 1.5 for our similar figure. The longer side length is 4 for our original, and it is 3 for our similar. And so now that I've found the corresponding sides, I'm going to go ahead and put them into my proportion. So I'm going to look at my 2 green numbers. And for my original figure, I have 3. And for my similar figure, I have 1.5. Then I'm going to look at my red numbers. For my original figure, I have 4. And for my similar figure, I have 3. So go ahead and do this cross multiplication. See if you get whether they are similar or not. If you get like 2 equals 3, that doesn't make sense because 2 does not equal 3. So we would say that they are not similar. If you get 3 equals 3, however, then you would find out that they are similar because 3 does equal 3. So pause the video and try this out. And hopefully you found out that they are not similar. So when we take 3 times 3, we end up with 9. And when we take 4 times 1.5, we're going to end up with 6. And since we've got 9 equals 6, that's not a true statement. That doesn't make sense. 9 does not equal 6. We're going to say it is not similar. So I have some scale factor practice problems down here for you. So we're talking about enlarging a photo. So we're taking a 4x6 and we're going to enlarge it to a 20x30. We're going to figure out what that scale factor is between the side lengths of the original and the enlarged photo. The scale factor between the perimeter of the original photo and the large photo and the area of the original enlarged. So remember that perimeter is when we add up all the side lengths, and remember that area is when we figure out what's the area inside of our photograph. And then down here, we've got a few other questions. So each pair of figures is similar, find the scale factor, then solve for x. So these problems 2 and 3 are just like what we did up here on this problem. Then we're going to move on to tell whether the 2 figures are similar and explain your reasoning. So 4 and 5 are going to be like this last problem we did. Are they similar or not? And then our last one is a review of what we did before. What are the corresponding parts of the figures below? Select all that apply. So when you're looking at this, you're matching up the angles. So I can see that this K goes with our 40 degrees. And so that means that K and V, which is also 40 degrees, are corresponding angles. So if I'm looking over here, I see angle K is equal to angle V, which is true because both of those angles have a angle length of 40 degrees. And so I know that those match up. So this is actually going to be one of your answers here. So you're going to go ahead and check these other 4. This line above it means side length. So you're looking at side length KM. So KM is going to be 41. So this right here is 41. So figure out where VW is and see if that side length is also 41. If it is, then you're going to select it. If it's not 41, then it is not an answer. So you're going to have multiple ones, see which ones match up. If you have any questions over this assignment, send me an email.